In this question, we need to drag the characteristics in the middle into the correct boxes to describe the two functions. You'll notice that the function on the left is written in vertex form, and the function on the right is written in general form. Before we get started, let's take a look at the graphs. Once we've placed the graphs in the right spot, that'll give us an idea of what our functions look like. Since the one on the left has a positive leading coefficient, we know the graph is opening upward, and the one on the right must be opening downward since it has a negative leading coefficient. Next, let's move on to the vertex. The vertex for the one on the left here looks to be at approximately -3 and -2. The one on the right looks to be at 4 and 1. The axis of symmetry. The axis of symmetry is always x is equal to whatever your x value is, like so. So we're looking for x equals -3. And the x value over here is 4, so we're looking for x equals 4. If you recall, the axis of symmetry is a line that divides your quadratic or your parabola in half and creates a mirroring effect. Now the opening. As we said before when we were determining what the graph was, we know the opening for our first one is upward, and the opening for the other one must be therefore downward. Now let's look at the x-intercepts. We can see that the x-intercepts are negative for this one. They look to be at approximately -5 and -1. And over here, we clearly have positive ones at 2 and 6. Next, let's deal with the y-intercepts. The y-intercept looks to be a little higher than 2, perhaps 2.5. And the y-intercept for this graph looks to be around -3. The domain. The domain for any quadratic is all real numbers, so both of these will be the same. And now the range. The range is talking about what y values are permitted. Notice that in this function we can have y values from -2 and above, so y can be greater than or equal to -2. And in this function we can have y values below 1, so y is less than or equal to 1. Finally, we need to determine which function has a maximum and which has a minimum. Because this is the lowest point on this function, it is a minimum value. This is the highest point, so it has a maximum value. Let's check our solutions, and we are correct.